The purpose of my brief talk is to demonstrate, with the aid of some experimental data, that in order to study and understand the dynamics of the neutral thermosphere, we have to have detailed information on the convection electric fields and the energy due to particle precipitation. I believe that most of you are familiar with what the calculated winds would look like if the only driving force would be that due to solar EUV heating. I only have a view graph of it, so not a slide, so I won't bore you with it. The winds predicted by such a model would be blowing from the subsolar point to the anti-solar point, modified by the Coriolis forces. So that means that in the northern hemisphere, just to orient you a little bit, we would expect the zonal winds to blow to the east in the evening sector and to the west in the morning sector, and the meridional wind would be blowing generally to the south in the northern hemisphere during the night. So now, what is really the situation, at least at high latitudes? The next few slides will show results of some measurements obtained about a year ago in Alaska, where we simultaneously measured ion drifts and neutral winds. The ion drifts were obtained using the Chattanooga radar facility, and the neutral winds were obtained by looking at Doppler shifts of some natural emissions, 6,300 angstrom emissions from atomic oxygen lines. Here are results from 5 nights in 1972, and these are supposedly vectors, and the circle around them is an indication of kind of the estimate of the error bar. I don't know if you can see it way back. And what it wants, this is to the north, south, east, west. Now, the point with this kind of mess of vectors, which is difficult to see, is that the neutral winds are varying from day to day. I mean, there is a significant day-to-day variation. But if you apply kind of an eye filter to this mess of arrows here, then the kind of thing that you see is that in general, in the pre-midnight sector, the neutral wind is blowing to the west and turning southward in the post-midnight sector. Now, again, as I said, there are significant day-to-day variations, but if you would kind of add them all up and get a general pattern, that's what you would find.
How do the 200-kilometer winds compare with the 120-kilometer winds that the radar derives?
Okay. Well, let me first clarify your question. Are you asking on how the 120-kilometer winds that the Roble-Hayes theory predicts, or no?
No, the 200-kilometer winds
measured by the 6300 as compared to the 120-kilometer neutral winds derived by Oscar Brakke. I believe the general trend is similar, and however, there are very definite differences. But the trend, the general circulation, the trend of blowing. I need hands to talk. Blowing to the west in the evening, blowing to the east in the morning, and the general southerly flow. That general trend is there for the 120-kilometer winds also. But the numbers are, of course, different, the magnitudes and the details.
The winds themselves were made to match at 300 kilometers. It is tied in the vertical by a Yakia-type gradient, and therefore there may be significant deviations the further you get away from 300 kilometers. But it is locked in that position.
Let me clarify something, because I think you what Ray's saying is correct, but I think he misunderstood Bill Hansen's question. Well, I think I answered your question. Now, what Ray is explaining about his model is that he really matched the ion drift and the neutral wind at 300 kilometers. Now, his model is such that it predicts actually neutral winds at different altitudes. But on how good that prediction is as you move away from the altitude where you really did all this matching. Depends on how good your vertical profiles are on temperature and so on.
Your ability to reproduce the temperature and density profiles is really astounding. What solar EUV flux values did you use here, Ray?
Okay, I'm using twice Hinneregger solar fluxes, and I'm using an atomic oxygen concentration of about 10 to the 11th at 120 kilometers. So to make this model work, one has to tune the solar flux. The overall shape of the contours is really very strikingly determined by the neutral wind. So one very carefully has to evaluate what the component of the neutral motion along the geomagnetic field line is. And then the shape of the contours can be reproduced. In addition, the electric field also has an influence on tilting the shape of these contours, and this may make a contribution.
This really speaks well for what one can do with one-dimensional modeling, I think. Really.
During quiet times, perhaps.
I think it's only fair to point out also that there are many other calculations that, for which one has to double the solar fluxes, as you did. Maintaining the global exospheric temperature in the neutral atmosphere, photoelectron escape fluxes, and other things also.
Yeah. Well, perhaps we will learn more from AE when it gives us results.